Two 100-to-1 harmonic drives. So, harmonic drive mounts. They seem to be all the rage. They also start at $2,000. I don't have $2,000 for a mount, but I want a harmonic drive mount. So, as you can see from the intro, I got a couple of these from Vietnam on eBay. I'm going to try and DIY my way into a harmonic drive mount. Plan is to keep the budget around $500, hopefully. Buy all the stuff from China. Going to run a belt drive system with stepper motors and of course on-step. I'm going to use the new on-step X. It has a lot of cool new stuff that I probably won't use, but I want it to be available for me. I'm going to use a controller card with 4 steppers instead of just the 2 that I have on my old mount, because if everything works good, I want to build a focuser too. So I'm going to be doing this all with the tools I have available, which is basically a bandsaw, a drill press. I don't have anything fancy like a lot of the water jet CNCs. I've seen people building these things on YouTube. I'll be building the case out of just aluminum plates that I can find as cheap as I can. It's not going to look pretty, but hopefully it'll be functional. So join me and we'll see if I can DIY my way into a nicer mount than I have already. So FYI, when you take all of these screws out of the back here, this, and I've already pulled some out again, this has a billion little needle bearings that I really don't want to mess with, so I'm going to put that back together. Okay, we're back together. Don't do that. So I've got the wave generator out. I basically tapped the drive on the tabletop here and it popped this out just a little bit, and then I took these needle nose, put them in here, twisted the shaft, which really spun the wave generator fast, and it popped right out. Okay, so if you guys don't know how a harmonic drive works, this is called the wave generator. It's basically a ball bearing that's elliptical, not circular, and it goes in here next to this metal cup here called the flex spline, which is some flexible metal that contours to the shape of the ellipse here, so when it spins around, this deforms too. And it has little teeny teeth around the outside of it, and on the inside of this solid piece of metal here, which is circular, it has teeth too, and they mesh together. There's more teeth on the outside than there are on the inside, and there's always at least 2 teeth in contact on each side, so when it spins you never have any backlash, which is the cool thing about harmonic drives. So I guess next I'm going to take out these screws here. Hopefully we can get the flex spline out, and then I can just clean everything up and re-grease it, and hopefully it feels a little better when it's running. These are hard to get out. They're pretty tight. When I try to do it, it actually spins the gear inside the thing. I don't want to do that, so I put a couple of screws in the back, bolts, whatever. I'll put them on, clamp them in a vise, and then maybe I can get these out without spinning. They do not come out, and I'm pretty scared to push even harder. I don't want to break anything, so we'll just try to clean it without. Alright, now we have it all clean, dried off, ready to get greased up and go back together. So first I'm going to try and rub a little grease down in between the gears right here. Hopefully. We'll be using super lube, of course. And once that's done, I'll do the bearing. Now we'll grease up the bearing. Okay, I've got to get this inside there very flat. This goes through here, and we got to keep that in contact with these. So I found this that's about the same size as the bearing. I think it's a lens cap of some sort, and we'll put this on here and hopefully we can shove it on flat. Okay, now use this to lift this up so we can put the snap ring back on. Okay, it is back together and super lubed. I had to put one of the set screws in here to hold this shaft and pull it up so I could get the snap ring in. That was about the hardest part of the whole thing. So it appears to work. We'll test this. We'll try this. see that turning, and you can see that turning there. And it doesn't feel like there's grit in there anymore. It spins pretty smooth. I still think I'll use this one for the deck. The other one, I don't know. I'll find out after I rebuild the other one, and that's the next project. We'll just tear that one apart the same way we did this one, and then we'll have our harmonic gears ready to go. Alright, so we got these all greased up and put back together, repacked. This one feels really good. This one still feels a little sketchy. I don't know. We'll work on that later. For now, let's look at some other cool stuff I got. So I have received a bunch of parts. I have a shaft, 8 millimeters. 8 millimeters actually happens to be the center there, so I'll cut that in half, use it for my pulleys. Speaking of which, I have 220 tooth pulleys, also with 8-inch shafts. The MT2 or M2T, I've got 10 millimeter wide ones this time. I went wider than I did on my other mount. I wanted this one to be a little heavier duty. So we got 2 of those. I got some 20 tooth pulleys with 5 millimeter diameter shafts, because that's what my stepper motors are going to be. I have some 10 millimeter timing belts. I got a couple of different sizes just to, hopefully I guessed right. We'll see. I have my stepper motors, 400 stepper motors. They're basically the same ones I have for my other mount. They seem to be powerful enough. They have the 5 millimeter shafts. This one actually has a brake on it. We'll be using that for the RA axis. I've heard with the harmonic mounts, since there's not really any clutches or anything, it's just the torque of the motors that hold the axes in position. So this brake is powered by 24 volt DC, and when it doesn't have 24 volt DC, the brake clamps onto the shaft and doesn't let this move. I'll be using a 24 volt power supply instead of the 19 volt I use on my other mount, and the controller board can use up to 24 volts, so that'll work out. I bought a dual saddle, Lost Mandy Vixen style. We're probably going to have to build a plate to connect this to this out of aluminum, and I'll be building all the cases out of aluminum to mount the drives and the motors in. My plan is to maybe mock something up out of wood first, so I can get the dimensions right and everything looks like it will work, and then I will build it out of aluminum plate. And since I bought a saddle with Lost Mandy plate, I just kind of had to for my telescope. Maybe that will help. Last but not least, the controller board. I bought the Max ESP4 board. It's built to run OnStep X, which is the newest version of OnStep. So there's a controller board. Basically all you have to do is, all of the surface mounted things are already done for you, so all you have to do is put the through hole pin connectors in and solder them to the back. kind of like a Lego set. Has all the pieces. Came with 4 stepper drivers, because also with this one you can see it has 4 places for stepper drivers instead of just the 2 that I had on my old one, because I plan to, once I get this up and running with just the RA and the deck axis, to build a focuser. And so that will go here. It also has one more for maybe a second focuser or a rotator, depending on what you want to do. Alright, let's get started with some fun stuff. So we're going to solder all the pieces together for the controller. I know just enough to be dangerous. I'm glad there's smart people who design these things and I just have to solder them together. So here's all the pieces we have to work with. Mountain Dew, yes. I do have a cheap rework station that I got off Amazon a few years ago. It's been working great. If you'd like to look at it, I'll leave a link in the description. Okay, first thing, we'll start with the LEDs. I have 2 of them. You can see one lead is longer. That's the anode, short one's the cathode. You can see where the 2 LEDs go right here. There's 2 little resistors that go to the right sides. That's usually the cathode. So we'll stick them in that way. And pull them out just a little bit and bend them over. I want them to be facing out like that. Solder. Next we'll do the 4 stepper drivers. Luckily the stepper drivers are already put together, so I'll just use those. For the template for the sockets. Cheating. This way. And stick them through. And I'll just tack the 4 corners, hold them in there. Put something under the other end to keep it from tipping. Okay, now we'll do the inside ones. Alright, now let's do the same thing to the ESP32 board. Tack it in place. Okay, now let's tack in the Wi-Fi chip. Okay, now I have all of those tacked in. I'm going to just go through and solder all of them. Okay, I just added a little flux. Hopefully that'll make it flow. Here we go. Okay, sockets are done. Alright, guess the next thing, we put on the buzzer. It does have a positive marked on the board. Just throw that on. Not too hard. Getting closer. Okay, next we got the power connections. So this kit comes with either, you can use the RJ45 and RJ11 jacks for power, or screw type connectors. I'm going to use the screw type connectors because most of my wiring is going to be internal on this, I believe. I'm going to put on the stereo ports, the power connectors, ST4 port. So they'll go put all the power connections right there, the screw connectors, power port. This is an 1/8" stereo phone jack, which can be used for a limit sensor. There's an automotive type fuse right there. On this side we'll have the stereo port and the ST4 port for use with a hand controller or something like that. So we'll do that. So I've got all connectors soldered on. Now all I have left is a 5-volt voltage regulator right there, a 12-volt voltage regulator right there. That's them here. And then some jumper headers right there, and right there. Alright, we'll do those and we will just about be complete. And here we have one Max ESP4 controller board. If you have any competency in through-hole soldering, you can do it too. Alright, next we got program it with OnStep X. Alright, this video has gone on long enough, I think. If you want to follow along, be sure to subscribe. Hit the notification bell so you know when the next one comes out. Then we can see if I succeed or fail. As usual, the clouds have been abundant, so I did get a couple of nights in imaging, so enjoy the Pac-Man Nebula.